All right, so just a general overview of what we will be talking about today. We'll do a brief introduction to MATLAB. We'll go over the interface, what it looks like when you open up the software. We'll go over some brief definitions. Then we'll talk about working with variables and matrices within MATLAB. We'll talk about importing some external data, and we'll go over some examples of how to extract certain pieces of that data and how to create some two-dimensional plots. So just a little bit about this workshop. I talked about sort of some of the things that we are going to cover in the last slide. Just because of the amount of time we have together today, this workshop will not be a full-on introduction to coding or programming just in general. This is going to be more specific to MATLAB, and we won't necessarily have time to do any deep dives into some of the applications and packages that come with MATLAB. There are tons and tons of those, as we'll allude to throughout, and those could honestly probably have their own session. But you're free afterwards, if you're interested in any of those, have any questions, feel free to follow up on that. All right, so what is MATLAB? So MATLAB stands for Matrix Laboratory. This is a numerical computing environment that was built around the MATLAB scripting language, and it was developed back in the 1970s. So it's been around for a little while, at least the original language. And it was developed by a mathematics professor named Cleve Moeller at the University of New Mexico. And they really developed it at the time to be able to interface with other coding and programming languages, such as C and Fortran, that were popular and in use in academic communities at the time. And Moeller's students then formed MathWorks, which is now the company that distributes MATLAB as a commercial and proprietary product. So MATLAB is really useful, particularly in the fields of science, engineering, and economics. And it allows the user to do a wide variety of things, such as performing matrix manipulations, hence the name Matrix Laboratory. You can plot functions and data within MATLAB, implement and develop different types of algorithms. And it's built, as I sort of alluded to earlier, to interface with programs developed in other languages, including C, C++, Fortran, and Python. So some of the advantages to using MATLAB, this is a common question since there's several different programming data analysis softwares out there. Why would you use MATLAB over something like Python or R or any of the many other softwares that are out there? So MATLAB has an extensive built-in analysis functionality, which means that you don't necessarily have to install a bunch of different packages or add-ons to get a lot of the functionality of MATLAB to work. You can implement and test algorithms easily. That is useful for your research. There's dedicated toolboxes for specific use cases if you're trying to do more complex analysis. One thing that is really, really nice is that there is extensive help documentation. So help documentation within the software itself and help documentation through MathWorks and other online free resources that are very useful if you're just starting out with MATLAB, you're just starting out and trying to learn the software. And then the last one is it's sort of, in comparison, that MATLAB has a quote unquote easy learning curve. All programming softwares do have a learning curve and do take some practice to work. But compared to some other software that's a little more complex, MATLAB has sort of a nice learning curve for those that are just starting out with data analysis software, programming software, etc. I once read a quote that said, essentially, MATLAB has engineering power without the need to be a software developer. So I always sort of keep that quote in mind, and you sort of see that when you start using the tool. All right, so now that we've talked a little bit about kind of what MATLAB is, as we're getting into using the tool, now we need to know, where can we find MATLAB? So at Florida State University, there are several locations where you can find MATLAB, and it's available for use. It is available within the libraries. So Strozier, Dirac, and Engineering Library, if you're in one of those locations and you're on one of the desktop computers there, there will be an option to go to a scientific desktop. And that has several of our data analysis softwares that we have available for access within the libraries. You can use MATLAB there. Some academic departments have their own licenses to MATLAB and make it pretty widely available. If you're in, say, the College of Engineering, they have fairly quick access to MATLAB for their students over there. And if you are looking to just use this online, if you don't have access to it on a desktop, there is an option called the FSU Virtual Lab. And I will show you just real quick how to find MATLAB on the virtual lab in case this is an option that you may need or you don't have access to it on a desktop. So I typically just search for my FSU VLab, just do a quick Google search. And it's this My FSU VLab under Information Technology Services at FSU. Here it's just the first search result. So I click on that, and then you'll see this sign in button over here at the right. And you should just be able to sign in with FSU credentials. And then you will be into the FSU VLab. And if you look here, there are several different softwares available. It's not just MATLAB. So this could potentially be useful for you in another scenario if you need to use another piece of software. But if you go down here, sort of on the left-hand side, you'll see MATLAB 2021A. And this is one of the more recent versions of MATLAB. So you can just click this and then access that from this tool. So there is, that wasn't on that screen, one other option. If you're a student, faculty, or staff at FSU, if you go into MATLAB FSU, you have internet access and space on your desktop. You can actually go to ITS, and you can actually download the MATLAB desktop software to use. So there isn't any charge as long as you're affiliated with FSU. There's just some instructions you have to go through in creating a MathWorks account to do that. But this is another option if you want a desktop version and you're not in the libraries or your department doesn't already have access to it. All right, now I'm going to go back to my slideshow. All right, so now that we know how to access the software, I'm just going to briefly mention I will be using a data set for some of the examples that I do here in just a little bit in today's workshop. So it's this data set right here from datausa.io. It talks about the different commute times in a few different southern states. Just Florida and Georgia and Alabama. So it's a sample data set that I pulled from here. Actual data. I'm using this for this workshop. You can put in this bit.ly link right here on the screen, and this should take you to a Google Drive with one Google Doc in it. So not a whole lot in it, but if we go to that, you'll see this commute data 2013-2019 data set. And you can download that to your computer, save that, and if you want to follow along today, please feel free to do so, or if you want to work on this later on after the session, you'll have that data set available to use. And I'll be sending out these slides after the workshop today as well, so you'll have all of these links available to you as well, anything that I show in the slides or during the workshop. All right, so before I go on and actually get into the interface, I just want to pause real quick, make sure everybody's in a good spot, see if anyone has any questions. Again, if you do, feel free to put them in the chat. If not, if you could, give me a thumbs up or green check mark sign using one of the Zoom reactions, or say you're good in the chat, and we'll keep going. Yes, I can share that link here. Let me get out of this real quick. All right, there you go. And that is the bit.ly link to access that data set. All right. So with that, we'll go ahead and continue. And I'm going to be getting into the software now and doing some demonstrations. So I'm going to turn my camera off for this portion. So you're aware of that. But now we're going to go into the software itself. So I'm going to share that. So I just want to make sure, because sometimes Zoom doesn't reshare things correctly. Can everybody see a MatLab home interface on the screen? Awesome. Awesome, great. All right, so when you open MatLab for the first time, this is what your home screen is going to look like. This is MatLab R2022B. This is the most recent version. They put out slightly new versions of this, I think once or twice a year. But if you're using the version on the MyFSU VLab, the 2021 version, it's pretty much the same, just with maybe a couple of things moved here and there. So you should be pretty good on that front. But the general interface is the same. Here at the top, you'll have a few different toolbars that you'll notice. You have your home toolbar, which has several different things that you can do, such as importing data, which we'll talk about in a little bit. It talks about scripts, which we'll also get into later on in the session. And then there's also some resources buttons if you want to learn more about MatLab, or you want to kind of look at some of their help resources directly in the software, as I mentioned earlier. There is also a plots toolbar that is useful for plotting data. It's one of the ways you can go about plotting data within MatLab, and I'll allude to this a little bit later on. And then this final tab that we see right now is just if you want to download any of those extra packages and whatnot that I talked about earlier. You can find some of those that are already available right here. But you can also search for more of those. There's tons of those available. So besides the toolbars, if you look on the screen, this middle part of the screen is what is known as the command window. This is where you're going to enter your commands. So any code that you're going to enter, any functions that you're going to define, where you're going to work with your data. You're going to do that within this command window. On the right-hand side, you'll see what's called the workspace. And that is where any variables that you might define, you do that in the command window, and any of those that you define, you will see those appear here in your workspace. So it's a nice way to sort of keep track of what variables that you have already written. You can pull those up again using the command window. On the left-hand side, you'll see a folder view, and this shows you any file paths or filing systems that you have come up with for your files within MatLab. You'll see that I don't have a whole lot in here. I recently downloaded this new version of the software, so I haven't really gone through and organized things too much yet. But you can use this to come up with an organization system if you're using this for lots of different analyses. And you can use that to call up different data sets into MatLab to do further work on. All right, so if we go out of that for a second and we think about a few different definitions. So once you're in MatLab and you begin entering values, at its kind of most base level, you're going to be working with scalars, vectors, and arrays. So scalars are a single value. So if you just type in a single value, define, say, a equals 1 into MatLab, that is known as a scalar. And since MatLab looks at everything as a matrix, it's going to view that as a 1-by-1 matrix. A vector is where we add a little bit more, and that is a collection of numbers in one dimension. So you can either have a row vector, so you have, say, one row and an infinite number of columns or an infinite number of values, or you can have a column vector where you have one column and sort of an infinite number of rows or an infinite number of values there. You put all of those together, and that is known as a matrix. So if we go into our MatLab to sort of show you what I mean, if we go to our command window and we go to, say, define a scalar, so we want to do a single value, we can give that a definition. So let's call that A. You always want to define your variables as well. And I'll show you what happens if you don't here in just a second. But let's say we want to do our A is equal to 1. We type into the command window A equals 1, and then we hit enter. You'll see that has outputted that value in our command window. And then if you look over in the workspace, it has outputted variable A, so the name that we gave that, with a value of 1. So that's what happens when we define our variables. As I mentioned, it's really important to do that. So if you don't do that, say you just type the number 5 and then you hit enter, by default, MatLab is going to define that as ANS or answer. And what happens in this case, if you were to do this, say you're doing some calculations, if you were to, say, enter another value, say 11, for instance, and you didn't define this, if you hit enter, now it's going to define ANS as 11. It's going to take the most recent output for that variable, for that name. And that's the case for any of these. So if we say A is equal to 2, that has now changed our A value to 2. So it's really important that you define your variables when you are working with them. So we've now done just the scalar, if we want to do a row vector, let's call that B. Say B is equal to, and then we're going to use these square brackets. This is what we use if we are defining a numerical matrix within MatLab. So we put our left square, left bracket, and then let's say we want to do 2, 4, 6 in one row. To define a row vector, you type 2, 4, 6, etc. So we use commas to separate the values if we want to define our row vector. And you see that outputted in the command window and then in our workspace as well. If you want to do this for a column, let's say we call that C. Again, you're going to use these square brackets. And this time, instead of using commas, you're going to use a semicolon. So you separate the values in your column vector with a semicolon, and then you'll see that outputs that in your workspace using the syntax that you typed in, and then outputs it in the command window as a column. If you now want to combine all of that and actually make a matrix, so sort of building our vectors and our scalars, now we want to define a matrix. We're going to do a 3 by 3, so 3 rows and 3 columns. You can type those in, say here, say 2, 4, 6. That can be our first row, and then say 1, 9, 5 for our second row, and then 3, 5, 0. Now let's do 2. All right, so make sure you put the brackets there. That defines it. So now we have our rows. We're separating those with a semicolon. And so now we have our matrix. And so this is how, if you're having to do manual entry, you're going to type those into MatLab. You may not, once you get into using more kind of complex data sets and whatnot and importing data, some of these may not be used as much, but this is sort of the base for how MatLab looks at scalars, matrices, and vectors, and how you enter those using the MatLab syntax. All right, so before I go on, I just want to make sure that everyone is still good. If you have any questions, please put them in the chat. If you're good, just go ahead and give me a thumbs up again, and we'll keep going. All right, awesome. Thanks, y'all. All righty. All right, and then most of these will be in the slides as well. So there'll be a quick little summary of what I just said about working with variables and coming up with your rows, your columns, and your matrices. And so then, as I say here, variables typically, what we're going to do for most of the day today, they'll have integer values, but you can also do text arrays as well within MatLab and sort of output those when you're working with plots, or kind of associate those with different matrices as well. So that is also possible. But now we're going to go into actually working with some data. So if I go back into my MatLab, real quick, I am going to clean up the command window a little bit. So if you're ever doing a lot of analyses and you come up with a lot of variables, you've got a lot of data within your window, it can be really useful to sort of clean that up a little bit so that you keep track of all those different commands. And there's a couple different sets of commands we can use for this. If you type in CLC to your command window, you'll see this clears out the command window of any syntax or commands that you put into there. But you'll see that our workspace is still there, right? So all of those variables are still there. Everything that we defined has not disappeared. So if you ever wanted to say, pull those up again, say you wanted to pull up B, you hit enter, and that pulls up variable B and our row vector from before. If you want to clear out your workspace, for that, we use the clear command. And there's a couple different ways you can go about this. You can clear out specific variables. So you can say clear out A. So that is going to clear out our variable A. But if you want a clean slate, if you want to just completely clear out your workspace, you can type clear all. And that will clear out your entire workspace. So these are just a couple of quick things you can do if you want to clean things up. If you want to still use the variables that you've defined in further analyses, I would recommend just using that CLC command so that you don't lose any of that, particularly if you haven't saved that anywhere up to that point. All right, so now that we've done that, we're going to go into importing data. So to import our data set into MATLAB for us to use, we can use this import data wizard up here at the top under the home toolbar and in the variable section. So if we click import data, what that's first going to do is it's going to bring up your sort of file window that you'll have on your computer so that you can search for a specific file to download. And MATLAB can read tons of different file types. I commonly use CSV files and Microsoft Excel files to import, but it can read hundreds of other different file types as well. And I'll have a link at the end of the presentation where you can go to see like what different types of files MATLAB can work with, because there's way too many to even count. So you'll go to wherever you have this stored. So I have this commute data 2013, 2019, and then I'm going to hit open. And so what that should do is it should bring up another window. And let me know again if you can or can't see this window. Usually it works, but sometimes Zoom, again, doesn't work. So there should be a window with the sort of Excel CSV file within here. And what you can now do is select how you want MATLAB to import that data. So what I have done here is taken this commute data from 2013 to 2019, and I've sort of summarized that a little bit for this particular workshop. All right, awesome. I'm going to, actually, I think I'll just share my screen real quick. All right, can you see it now? Awesome. Yeah, I know sometimes Zoom will work and sometimes it will not with those kind of things. All right, so you will see this type of screen when you first are uploading your data, and it will show, this is where you essentially select how you want to import this into the software. So I have taken this data set, I have sort of summarized it down a little bit for purposes of this workshop. So I have commute data for different states and then the US by year. And so what I'm going to do now is this will be sort of a little quality of life thing. But you'll see up here in this little text window here, you can actually redefine what you name this. And this will be important because this is the variable name that's going to get imported into MATLAB. And you'll see why that's important here in a second. So I'm going to shorten this to commute 1319. You can, in theory, use pretty much any one that you want. You'll then want to go to this output type. So you should see by imported data, you should see output type. You go to table. If you go to output type here, go down to numeric matrix. And then over here, you'll see import selection. And if you click the little down arrow here, you'll see a few different options. We're going to just select this import data for now. But there is this generate script option, which will become important a little bit later on in the presentation. But for now, we're just going to select import data. And you should see the following variables were imported. So it's imported this commute data as a 7 by 5 matrix. So we have 7 rows and then 5 columns. And so I'm going to just go back into regular MATLAB. And you'll see this over here in our workspace. I always like to do a quick check to make sure that it uploaded my file successfully. So you just type in the name of the variable, as I've done before, commute 1319, and hit enter. And then you'll see that outputs our data. One thing that you will notice is that since we had data in the previous, when we uploaded this, we had sort of years, which were kind of full integer values, and then we had integer values with decimals. MATLAB likes to keep all of these consistent. So it sort of adds this 1.0 10 to the third. This is the same exact data as before, and it will look exactly the same at the end. But you will notice that when you have sort of different significant figures types of things within MATLAB. All right, so now that we've uploaded our data, now I'm going to chat about extracting data. So say you're working with a data set and you want to extract some of those values from the data. Maybe you want to do specific analysis on like a certain section of the data or a certain row or a certain column. There's a few different functions that you can use for that. So if we go back to here, let's say,
I have a question.
Yes.
Yeah, when I import the data, some of them is like appear none for the rows, sorry, for column 6 and 7 and 5. I don't know, is usually happen that or I make something wrong?
So you're saying that there were no values that
for 1 and 3 and 4 column, for 4 columns there is a number, but the rest is none for 6 and 7. Like a bit like this one. I will like send them in the chat.
Okay, yes, that would be yeah, that would be great. Yeah, sometimes, yeah, depending on what you selected for output, it might have done that, but
like this is like one row.
Okay, so when you're importing this, yeah, so yeah, one thing to make sure of is that all of the cells are kind of importable. So you'll see up here, it replaces, I guess I'll go back to sharing my actual screen here. You'll see up here where it has this replace unimportable cells with this NaN. If you select one of the options where maybe it has those cells, and then try and import that, it's gonna import those cells like this.
Yeah.
So yeah, I made sure with this. And so make sure also, I do have 2 tabs here, that you're on the commute summary tab.
Yeah, I think, yeah, I chose the first one. This
Yeah,
is,
yeah.
sorry. Yeah.
No, that's all right. That's a great question. Yeah,
Thank you
you'll
for
see.
the explanation. I appreciate it.
Yeah, you're welcome. Yeah, you'll see some of these are highlighted here, so it's kind of telling us that. But
Okay. Thank you. I will do it.
yeah, yeah, you're welcome. All right. Awesome. All right, so thinking about extracting our data. So if we want to say extract a specific value from somewhere within our data set, say we want to define that as x, so we can type in x equals, then you're going to type in the variable name, which is why I mentioned earlier, I do this to sort of save some time when I imported this data, calling this commute 1319. You have to type out that whole variable name or copy and paste it each time. So just do this for kind of speeding things up a little bit. But what you'll do is then type out that name, use a regular parenthesis, and say we want this value here. So say we want this value from our second row and our second column. So we're first going to type A2 for row 2. We're going to do 2, comma 2. So you'll have your row, comma, column. And so if you then hit enter, you'll see this outputs this value right here. And then, as I sort of alluded to earlier, this has our actual value in here. So you'll see that it's outputted the correct value. So that's one value. If you want to do multiple values, say you want an entire row or an entire column, you're going to start out pretty similarly. So say we define that as y, we say commute 1319, and then say we want all of a particular row. So we'll say like row 4. So we're going to say 4, comma, and then if you want to return everything, if you want to select all from that particular row, or say all the column values, you're going to use this colon. So this essentially here is telling MATLAB to pull all of the different column values from the 4th row. So if you hit enter, you'll see if we go up here, try and highlight this a little bit to make it easier to see. So you'll see it pulled from our 2016, it pulled all of these values here. We can also do this for pulling out specific column. Pretty similar, just now we'll have our colon before the comma. So we have all the rows in, say, column 2, for instance. Make sure to close our parentheses, hit enter, then you'll see that pulled, it doesn't highlight as nice, but that pulled all of our values from column 2. So that's for specific rows and columns. You can pull multiple at a time as well, also known as a slice. So if you hear somebody say they're pulling a slice of a particular data set in MATLAB, they're essentially talking about pulling a particular section of like rows and columns out of that data set. So I'll just do one quick example. So say A equals commute 19. So say I want to pull out, say, rows 2 to 4. So say I want to pull out our second, third, and fourth rows from our data set. So we're going to say 2:4. So this essentially means pull out all of the values from row 2 to row 4. And then comma, and then on the other side of the comma, we say which column values we want from those 3 rows. And we will just say all of them. So we just type our colon, hit enter, and you'll see that will essentially pull out our 2nd, 3rd, and 4th row. So you can do this for different columns as well. This can be particularly useful once you get larger and larger data sets. If you're wanting to work with specific portions of them, you can sort of see all of the data today. But if you get, say, a data set with like hundreds of different values, this can be really useful if you want to pull out specific things and do analysis on specific portions of the data. All right, so I am going to, before I clear out the command window, go to plotting. Just going to quickly make sure that we're all good. See if anyone has any questions. Again, if not, thumbs up. And we will continue.
I have a question.
Yes.
How space sensitive is MATLAB? Because you're not putting in any spaces between a lot of your commands.
Yeah. So it sort of depends. So if I say here, so say I put in a space here just to define the variables, right? So say like a equals space here. This should still output the exact same thing. Or maybe it doesn't. Oh, I think I spelled this wrong. It doesn't. So I was going to say it's space sensitive in certain instances. Oh, okay. So I didn't put a space here. It's not letting me do that. So it is somewhat space sensitive if you put spaces, say, between like your, say, like your variable and your, like what you're trying to pull from. MATLAB won't recognize that unless you define that previously. But I believe if, say, you have like up here, it put like variable space equals whatnot, I believe it can still read that. But I know in some older versions, it wasn't as sensitive here, but it looks like here, once you hit that equal sign, unless you have that defined before, it might not recognize that. So I would say be on the safe side. You know, you can leave these spaces, kind of your spaces between like your variables and whatever you're defining. You don't necessarily have to put spaces here unless you want those as part of your variable name.
Thank you.
Yep. All right. So I am going to clear this. So I am going to clear our X, Y, and Z because I am going to use X, Y, and Z for something else, but I'll keep our commute data in here. So if I type commute 1319, hit enter, we'll have that. All right. So now we're going to look at doing some line plots within MATLAB. And I'm going to quickly go back to the slideshow. And this is just a very quick intro to line plots. There are many different types of plots you can do within MatLab. Within MatLab, you can do line plots in either 2 dimensions or 3 dimensions. You can use either linear or log scales. Today, we're just going to do some simple linear scale plots, just to sort of show you how that works, how you would set up those plots within the software. So if we go back to our MatLab, so the first thing we need to do before we actually do those plots is actually define what variables we're going to be plotting. And so what we want to do here is we're wanting to plot our commute data with our year on our x-axis, and then all of our different times represented on our y-axis. So we're going to do an XY plot. So what I'm going to do is we're first going to define our x, and what we're going to do here is for our commute 1319 variable. And then here we want to use all of the different rows in column 1. So we're going to have our colon, comma 1 in parentheses. And then I'm going to use this little semicolon at the end of our function. And what that is going to do, if you do that at the end of your function before you hit enter, that's going to suppress the output from your command window. So you'll see it still defined it in our workspace, but it didn't output it in the command window. And this can be really important if you have a larger data set you're trying to save on processing time and processing speed. Outputting this in the command window can take time and resources. So it can be useful to use this sort of suppress command here, where you're still defining it, but it's not taking the time to output it in your command window. So now that we've defined our x, I'm going to define our different y's, and I'm just going to use y1, y2, etc. for this. So now we're going to go through each column. So our y1 is going to be our second column. We're going to suppress that output, and you'll see as I do this, it's going to define those in our workspace. And I should end up with 4 of these at the end. They're all very similar. And we'll see a way to sort of speed this process up a little bit here in a couple minutes. But we'll first do it all on command window. So now we have defined all of our different variables. Now we can actually work on plotting. And depending on what type of plot that you're actually going for, there are actually different commands for plotting those. And you can look up within the help documentation or on the MatLab site what each of those is. But for line plots, they decided to just use plot for that, probably the first one that they actually set up. So for that, we can use the plot command. Before we do that, we want to make sure that we get all of our lines onto our graph. So you'll remember we had 4 different essentially lines that we were plotting. We had 3 different states plus 1 for the US as a whole, and then we were comparing that to the year. So we're going to have 4 lines that we want to all get on our plot at once. And so for that, I'm first going to define a figure, call this figure 1. And now I'm going to share my actual screen again so that y'all can see that. All right, and so you'll see here, there should be this little figure 1 box that pops up. And this is where our plot is going to appear. We haven't plotted anything yet, so it's blank at the moment. So then I'm going to use this hold on command. And what this is going to do is it's going to allow us to plot all of our different lines in succession. Otherwise, you have to sort of say plot X and Y1, X and Y2, X and Y3. It's going to try and plot them on different figures, or it's going to try and plot them over each other. So this is telling MATLAB essentially to plot all of those on the same figure. So what we're going to do is we type the plot command, and then we say X, and then Y1. So we're going to say X, Y1, and we're going to do this for each of our Y values. So if we say X compared to Y2, plot X, Y3, and then X, Y4. And then when you are finished plotting those different lines, you can type the hold off command. So that'll essentially remove that hold. Anything else from that point on that you would plot, if you don't, activate a new figure, that's going to plot over the figure you have, or if you do a new figure, it's going to plot on a separate page. So now I'm going to go down here, and if we bring up our figure 1, you'll see that now we have our 4 lines corresponding to our 4 different sets of data. We have our years on the x-axis, our minutes on the y-axis. You can go using this plot window. You can actually go in and insert labels. You can go in and insert an X label, Y label, a title, etc. So if you want to insert an X label and say year, a Y label and say how much time in minutes. And then I'm going to do a title and just say commute times. And so, and then you can also, especially for if you're looking at this data later, or if you want to export this data elsewhere, you can create a legend. And this, you'll see we have 4 lines. So there are 4 different things that you can actually define. And you can actually just go in to do this within your plot. And I am not sure where that orange errors came from. Interesting. I did not see that yesterday. That is new. All right. So I will get to that in just a second, and essentially what orange and red means, because we did see a red error a little bit earlier, so that can be important to know. So I'm cheating a little bit, and I know what each of these lines stands for. But you can also go back into the spot where you uploaded the data earlier to see what these correspond to. Just for the sake of time, I'm going to go ahead and define these here. So our blue corresponds to our Florida commute times, our red to our Georgia, our kind of light orange, yellow to Alabama, and then this like dark purple to the US. And you can go back into your window earlier that has all of your data, and you can sort of compare those just to sort of, compare and make sure those are exactly the same. So like Florida starts at 24.8. That's pretty close. 24.6 for the US. So you can do that here. So just a little aside, because I did mention these like orange warnings, red error things. So whenever you see this orange text within MATLAB, it calls this a warning. This does not prevent you from executing commands or executing something else within MATLAB. This is essentially saying that, maybe there's some errors in like graphics or how those are illustrated, or maybe there's something that it's trying to pull, but it can't find. So these are sort of like non-fatal errors, so to speak. But when you saw the red error earlier, that's essentially MATLAB saying, I can't find something, I can't recognize this, I can't execute this. So it won't let you move forward in that case. As I said, I have not seen this one before. I think this has something to do with graphics. You can actually usually go into MATLAB help and find out a little bit more about this if you have questions. But that's sort of the difference if you see that orange text or that red text when you're doing something within the software. All right. So now that we have, now that we've done our plot, so you'll see you can take this, you can save this as a particular figure. You can save this as like a PNG file or a TIFF file. So that if you want to outport this to like another document or to a port or something like that. There are other tools in here that you can use to clean this up a little bit. But for the sake of time, we won't necessarily go into every single one of those today. But one thing that I want to do before we close out for today is I want to show you all a different way to sort of set up all these analyses, import this data, and sort of get to the point that we were at before. So what I'm going to do is I'm going to clear this out. I'm going to clear everything out before. I'm going to close all of these windows so that it doesn't come up with an error message. And for this section, we're going to use something called a script. So you'll see these little buttons for scripts over here on the left-hand side. And scripts essentially consists of sequential lines of MATLAB commands. So these are text files, essentially within MATLAB, that allow you to run several different commands at once. Instead of having to type each one of those in the command window, as we've done kind of throughout the session. And they save these scripts within MATLAB with this .n extension. You'll see here a couple of example scripts. And if we go to one of these, I'm going to go to one that I've already started up. So if you want to do a new one, you can go to this new script over here. And anytime that you open a script, you'll see that there's a few new buttons up here at the top. You'll see that there's this editor tab, there's a publish tab, and there's a view tab. So this publish tab just has a few different things you can do with your text, sort of like the word processor. The editor has pretty much everything that you need to do to actually write out your script and then to run it later on. So I usually stay within this tab. And so you'll see what you can do. You'll see on the screen, there's a couple different ways that this text looks like. You'll see these sort of green text. I don't know why they chose this color as the default, but you'll see this green text with this percentage sign in front of it. These are what are known as comments. And this is text that you write into your script to sort of write reminders of your data set, what the data set is about, sort of what you're doing with that data. This does not get run by MATLAB. if you run this particular script, you try to execute this. This was just kind of there for you as you're keeping track of your data, or if somebody else is coming back to this data later and wants to do some analysis on it. So you'll see that I've typed in some of those commands from earlier when we were defining our X and our different Ys, and when we were plotting our graph, and then talking about what those plots were about. If we go into our import data again, if we go up to here and we go to import our data, you'll remember earlier when I went to do this, if I go to say commute 1319, you'll remember that over here in this import selection, just making sure everything is the same as before, you'll notice that it said generate script. And so what that is going to do is it's actually going to generate a script for importing this data. And so when you do that, it's going to look like this. And so it's got all these different things on here, not as scary as it looks. It's commenting out a lot of this very nicely and sort of dividing it up into sections. They've made scripts a lot more dynamic in the last few editions of MatLab. But you'll see it's importing data from spreadsheet. It's saying where that is coming from on your particular computer. It's saying what worksheet. So remember, we had 2 worksheets. So it has this commute summary on here, and it's saying the date that it generated this script. And this,
again, please, because we didn't see the screen that you did to grab the script.
Okay, so going back here, yes, I can do that.
Thank you.
All right, so I can show you how I got to that section, which I think is what you're asking.
Yes.
Awesome. Okay, so if you're on your sort of import data screen, I have it on the commute summary tab, everything similar to what we did earlier. If you go to this little import selection box and go down here to generate script. So earlier we did import data. This time I did generate script. And what that did is it generated this script that you see now.
Okay,
And so,
thank you.
Yep, you're welcome. And so this is essentially how MatLab would import this data. All of these different commands here are, this is the ops or different options. And this is essentially everything that we saw in our window here. So like we imported this specific range, we outputted it as a numeric matrix. So it's essentially defining all of this here and defining what all of our variables are. This can be useful if, say, you want to come back to this data set later, or you want to run similar analysis on another data set, but you just want to, say, import a different file or from a different place. So you can just replace the different things within your script. So what I'm going to do here is I'm going to copy from here. And if I go back into this MATLAB workshop script, you'll see I conspicuously had a little spot where I said insert script for importing data. I'm going to right click and say paste. And so that's going to paste in that previous script that MATLAB generated into here. So now you'll see it has all of your options for importing data. It has then the kinds of analysis it's going to do after that. So if you wanted to say, use this same analysis, but for like a different data set later on, you come back into this same script and you can go in and change the different variables here. So if we do this, I'm going to go up here to this editor just to kind of show you what happens. If we go to run, which is this sort of green arrow here, you can go to this run code right here. So if we run this code, you'll see what this did is it imported our data, it defined all of our variables, and it plotted everything. This time it happened super, super fast. Sometimes, especially if you have a lot of data, it will take a little bit of time, but this time it went really super quickly. So that is another way that you can get your data in. Personally, I like using, if you're just working with a data set, especially for the first time, I like using that import wizard. That's really nice. But you can, if you anticipate doing similar analyses on other data sets or that data set again, you can generate that script so that you can do that similar analysis in the future. And you can save those right within MatLab. So if you just go up to this save button, you can save those scripts and pull those up later whenever you're using the software. All right, so we are almost out of time, and I believe I got through everything just right on there. So if after this session, you're kind of working through this data, you want to learn more about MatLab, you guys want more resources, there are several different places that you can go. There are documents on how to import and export data, a little bit more details on things we talked about today. There's a list of different function commands that MatLab offers. So there's hundreds of different functions for different scenarios. So if you want to see what all of those are, what all they mean, there is a listing here on the MathWorks site. Then there are some community resources as well, such as a MATLAB YouTube channel, some LinkedIn learning resources, and then some Stack Overflow resources, which essentially is a community of programmers and others that are using the software. If you're having like errors or issues with the software, a lot of these have probably been seen by others within the community, so it's sometimes a good place to, find solutions or ask for assistance in that sense. And so then finally, I put my contact information on the screen. If you have any questions after we leave today, or if you would like, more specific assistance on a project that you're working on or anything that you're doing within MATLAB, I am available to work with you on that. Feel free to send me an email and we can get in touch. And with that, thank y'all for coming today. You've been a great audience. We'll send out a copy of the slides and this recording at some point after the session. But with that, thank you very much. Y'all have an awesome rest of your afternoon.
Thank you so much.
You're welcome.
I have a question about the graph. Could I specific the interval of the time to start like from 0 to like 660, or is like other function we could use to specific like the parameters for y, instead of started from 23rd and a half, could we start it from 0?
I do believe you can change that. I know that here it sort of imported this automatically since it kind of looked at our lowest value, which was kind of right above this 23.5, and it went up to our highest value. Oops, that is not what I meant to do. But you'll see if we do scroll up and down, you can still see these tabs here. So I believe that you can do that. Here it's just doing it dynamically. So I think you can just do it right here. If I go maybe to axes, if it decides to load for me. I believe if you go into these, sort of some of these different tools and like, actually it's not loading for me, but you can actually define this from say like 0 to 60 or sort of change how it outputs these specific numbers.
Okay, thank you.